Okay, this is just a review. I've already put the permutations for the test. Okay, so anyway, so the three special types are circular, distinguishable, repeated elements, conditional permutations, and that's about everything we have on permutations, right? Well, what else, though, as far as factorial that a lot of you missed on the quiz? You may remember? Very good. We might want to put in here something about that 0 factorial is 1. Okay. Okay, then we also had combinations. This is still in 6-7. And combinations are where order does not matter. So when you have the combination of n things taken r at a time, you'd have n factorial all over r factorial n minus r factorial. Okay. Now, can I use the blank method on this? No. The other thing that you can use, okay, what are my situations? Like here, how we said first, second, third, what are some key words? Group, team. Anything else? How about a committee? How about to pick you to be in a class? I'm thinking. A collection. All of those things. Now, where else do we use combinations besides those situations? Right, very good. To expand the binomial. Binomial expansion. So if I have a plus b to the n, how many terms do I have in it? n plus 1. And remember, let's just make this a 5. Then this would be 6, right? Okay. And then you would start out and be 5, 0. Oh, why did I do 5? 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. And you have A and B. And then how do the exponents of the A term go? Do they go up or they go down? Down. 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. And you add them together. Okay? What else could I use instead of using the combinations? What was our other thing that we used? Pascal's triangle. And remember, these are also always symmetric. Okay, if this is 5, then this is 5, and this was 10, and this was 10. That's for the combination part. Okay? You could also use Pascal's triangle. And here you'd have to make it and Miss Newman, what did you say one time?
What did I say?
I don't know.
I'm sorry, I'm not paying attention.
Oh, I know. Something about Pascal's triangle. You brought up another interesting thing.
Oh, the hockey stick?
No.
No.
It was something about... okay, maybe it'll come to me. About... Oh, that this number is always the degree of the exponent, right? The second
number,
yeah.
yes.
The second number in Pascal's triangle, this would be taking it a plus b to the 5th. This would be a plus b to the 4th. You could also find just this here. But remember, if this was 2a, you'd have to take 2a to the fourth and 2a cubed. Right? So this isn't your final answer. You still have to work those all out, correct? Do you all understand? Okay, so we had that also. We also had find the rth term. Find the certain term, the rth term. And the rth term would be, if you'd have this would be r minus 1. So if I wanted to find the fourth term, notice here, this is my first term, this is my second term, this is my third term, fourth term, fifth, and sixth. I do not want you writing out the whole expanse and finding the fourth term. The fourth term, this number is always one less than the term you want to find. And then I would have A, and I'd have B. And B always matches here. Okay? 4 and 4. And then this would be n minus the r minus 1. So let's do an example. And I'm going to do something a little bit harder. If you'd have something like this, and I'd want you to find the fourth term. Let's say find fourth term. Okay, so I know it's going to be 4, but what will this number be? 3, because it's always one less. I have x and I have negative 2y. Now, if I would be doing this with Pascal's triangle, I would be going like, well, this will be, this would be just 4 here, the fourth term. But that's not my final answer because this is 3, this is 1. This would be x and negative 8y cubed. So my final answer, and I want the negative in the front. I don't want it back in the term. I'll take off a point if you have the negative with still the y. Okay? You're multiplying negative 8 times 4, you get a negative 32. Okay? So that kind of takes care of all of that stuff. Then we went to 9-7. And 9-7 was just with multiple events. And this was when you had some overlapping. And you had, if you have the probability of A and B, everything we've done since the last test, you multiply them. We will put it. Okay, if they are mutually exclusive, it's the probability of A plus the probability of B. If they're mutually exclusive in a Venn diagram, there's nothing overlapping. If they are not mutually exclusive, then we have to subtract the overlap. So we have the probability of A plus the probability of B minus the probability of A and B. And this is when we got into rolling of a die. And you had that on your test, on your quiz. Okay? So that was basically that part. Then we went into 12-6. And this I'm happy to get to today because this is binomial distribution, and I want you to make a note of this and how it's different from finding this rth term. In a binomial distribution, this is about your successes and failures. How many successes out of how many tries you have? How many wins out of how many games? And what it is it is the combination of n, x, where p are the successes. Notice I take that to the x, and my failures are q minus x. On here, N stands for the number of trials. X stands for the number of successes. P is your probability of success. And Q is your probability of failure. So if I want to find what is the probability of 2 out of 7, no, let's say 5 out of 7 successes. I wish you were writing this down, Kanyar. And your probability of success is 60%. How would I set that up? I'd have the combination of 7 things. I have 5 successes. This would be 0.6 to the 5th, and this would be 0.4 to the 2nd. Because if I have 5 successes, I have 2 failures. This would be something defective and working, right? If something's working or it's defective. It's like a black and white. Okay? As far as success and failure, yes, no. 2 choices. Okay, we'll just, Sarah, listening to me.